Welcome to our Week 2 lecture. This is probably the first online room you've been in our class, and hopefully this method of flipping our classroom will be successful. I'm really interested in giving it a try, and I'd like to get your feedback, so be sure to let me know what you think. Our first lecture will be about developing number concepts. We talked during our last meeting, or the meeting before that, about counting and concrete and abstract and all the things in between. So you may recall that I asked a question as to how many fish are in the fish bowl. And if you missed that discussion or you forgot, the actual answer is none, because this is not a real fish bowl. It's a picture. And that can cause some problems with children that have not yet progressed past a concrete level. A picture of fish is not concrete. It's semi-concrete. Therefore, it can cause problems when you ask questions about the fish or the bowl, or other objects that are not actually used in a concrete fashion. So we have to be careful how we teach concepts to young children. I have a Prezi where I want to talk about how to get from a picture or a plate of goldfish crackers, which would be actually concrete as opposed to this example, to get to counting these objects in a way that is actual true counting. We need to teach children some pre-number activities. So I have a Prezi which will go through some of these steps. I hope it is displayed fairly well in this online room. It might be a little grainy or a little herky-jerky, but I think it'll at least get the point, and I'll try and go through it slowly. So here's a Prezi for you about developing number concepts. And in order to develop the true concept of numbers, we need to teach children some pre-number activities. And I'm sure that you've seen pre-number activities in early childhood settings. You maybe didn't realize they were math activities, but they are activities in which we're trying to help children develop their number concepts. A very common and powerful pre-number activity is classification. You'll see a lot of classification going on in early childhood settings. I'm sure during your pre-KK block you observed classification. In this example, this picture that you see, we have a simple one-loop Venn diagram where objects are placed inside the loop for a certain reason. I am assuming the reason in this case is that the objects are green, but there may be some other reason that they could be in this loop. But the bottom line is we need to teach classification. And in simple terms, classification is being able to group objects because of a characteristic. That's just one pre-number activity that you'll see and that you need to teach. Another example of a pre-number activity is something called seriation. This is a little more advanced form of classification. Seriation is just simply putting objects in order according to a characteristic. Grouping them according to a characteristic is a little less abstract. So that classification typically is taught and mastered before seriation. You can see in this example that the objects seem to be placed in order according to their size. It might be their height, it might be their width. It's not real clear, but they're placed in order. That's called seriation. Another example of pre-number activities that you have seen and you will teach is working with patterns. Most often, we think of patterns as shapes, colors, sequences, patterns of those things. But don't ever forget that our numbers make fantastic patterns. And you can see in this example different patterns just in the numbers of 0 to 29. There's plenty of patterns, and giving children opportunities to work with these patterns, extend these patterns, is tremendous help in learning number concepts. Another example that we teach children that helps with their number concepts is one-to-one correspondence. We give them lots of opportunities to work with objects and put, say, a tally mark in this case, which is semi-abstract because it's not an actual object representing the boxes of raisins, but this is an example of one-to-one correspondence where a child has made tally marks to keep track of the number of raisin boxes. We spend quite a bit of time with one-to-one correspondence. I want to also mention two different types of counting that you will encounter: rote counting and rational counting. And I guess as a good example, when my son Corey was only about 2.5 years old, he could count to 20. And we never hesitated to show that off to our relatives or friends or anyone that would watch. So, Corey, show them how you can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. And people would, oh, wow, that's so impressive. You can count so high. But if I would have shown Corey this picture of fish, remember this is not concrete, it's semi-concrete, but let's say I had a plate with goldfish crackers and said, Corey, how many fish are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. He could count, but it was an example of what's called rote counting. It's just a memorized string of words. It's impressive, but it's not counting. It's just memorization. What we want to teach is rational counting. We want to be able to count and put a word with a symbol. So what we need to teach early childhood children is rational counting. Count these objects. 1, 2, 3, 4, 5, 6, 7. Now you didn't see me touch them, but that's how I counted them. It was not rote. Now rote counting has some advantages and has help does help a little bit with rational counting, but rational counting is where we're headed. So let's talk for a few minutes about some possible errors that children will have when they're actually counting objects. I'm going to switch back to the whiteboard here for a minute in this online room and share with you some examples of counting errors that you probably have already seen. But if not, when you go out and block, you're going to see them if you're in the age where children are learning to count. So, ideally, we want to count 3, 4, 5, 6, 7. We want to count 7 objects. We want to either use a marker or something to cross off the pictures of fish as we count them, or better yet, if we have a plate full of goldfish crackers, how about we eat one every time we count it? That would work. So here's the problem. What if someone doesn't get 7? They're learning how to count, so they make a mistake. What kind of mistakes could they make? Well, here's a very good or a very likely possibility. Watch as I count the objects. 1, 2, 3, 5, 7, 8, 10. Woohoo! There's 10 fish. What did I do wrong? Well, my sequence is wrong. This is an example of what's called a sequence error. Rote counting probably could have helped with this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I'd have really remembered and understood what I was doing, I probably wouldn't have got 10 when I counted these objects. But putting a symbol and a word with an object sometimes gets in the way of other skills, and in this case my sequence was wrong, so I did not get the right answer. That's a sequence error. Are there any other possible errors? Yes, there is. How about this one? 1, 2, what comes after 2? Oh yeah, 3, 4, 5, 6. There are 6 fish. I touched them, I counted them, I got 6, and I was wrong. What did I do wrong? Well, it's a very simple error. It happens a lot when children are learning how to count. It's called an omit error. I just omitted an object. It would be helpful if I had real objects. It would be helpful if I was actually drawing on the page if I didn't have real objects. But in many cases, children just point out and touch objects, and it's easy to omit. And obviously, the more fish or pictures of fish there are, the more possibilities with omit. Very similar problem would be something like this. I can show you with a pen here. If I were actually using a pen, or a child were using a pen, or eating the goldfish crackers, they probably wouldn't make this mistake. But we tend to give kids worksheets all the time, so they just touch them and count as they go and write the answer. Here's what happens. 1, 2, I always have problems with that. 3, 4, 5, 6, 7, 8, 9. Yep, there's 9 fish. Understand that if a child was actually crossing the fish out or eating goldfish crackers as they went, they probably wouldn't make this error, but in most cases, children just point and count, and this type of error is called a double count error. Pretty fancy name, huh? All I did was get a little confused with my sequence possibly, or struggled a little bit, and actually counted a couple more than once. Pretty common error, easy to fix if you have actual materials or concrete objects. And here's one more type of error. I'm sure some of you have seen this. It's probably a little odd if you've never seen it. It's an error that you would just like to say, stop doing that. Don't do it that way. So here we go. I'm going to count the fish. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 fish. No, John, that's incorrect. Would you like to try again? Yes, I will try again. 1, whoops, forgot my little pen here. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 fish. I told you there were 8 fish. No, John, you're incorrect. This error is an error that I would like to pull my hair out with, or because of. It just doesn't fit my thinking. It's called a coordination error. The child looks at the objects and is kind of like a teenager when they're going through a growth spurt and they trip over nothing. The coordination is just messed up. The child starts counting too soon, or the child doesn't stop soon enough. So one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I was wrong. There's 9, not 8. Coordination error seems kind of silly to us abstract thinkers, but We're trying to do one-to-one correspondence. We're trying to remember a sequence. We're trying to put a symbol with an object. It's pretty complicated when you haven't done it before. So a coordination error is not uncommon. As a matter of fact, it's quite common. So let's go back to the Prezi. And I hope this is going okay for you so far. So we were looking at errors. We have a sequence error where the sequence is incorrect. Maybe the child actually counts the objects properly, but the sequence is wrong. An omit error where somewhere along the line an object is left out. A double count error, which is very similar, where an object is counted more than once. And then the error that seems to make no sense to most of us abstract thinkers is a coordination error. To help with counting and working with number concepts, there are a couple types of materials you will use in your early childhood classroom, and possibly beyond early childhood. But the two types of materials are called proportional and non-proportional. When you think of learning place value or base 10, it's probably common for you to have seen base 10 blocks. The picture on the left shows base 10 blocks. You have a small block, which is called a unit. You have a stick, which is 10 units, usually called long. You have a flat block, which is 10 longs, usually called a flat. And then there's a big block, which is actually 10 of the flats put together. The point here is that the materials are proportional. So one of those longs, the stick, is actually the same size as 10 of the small ones. And one of the flats is actually the same size as 100 of those small ones, or 10 of the longs. These are proportional materials. We need to give children plenty of opportunities to understand number concepts by working with these materials. Now, to build even deeper number concepts, we often introduce non-proportional materials. And we, as adults, work with non-proportional materials all the time. The way non-proportional materials work is that in this case, chip is worth a certain number of other chips. Think of it as money. If this green chip were a penny, what is a nickel? There's only one nickel, but it's actually worth 5 pennies. That's non-proportional. A nickel doesn't look like 5 pennies. Let's go to a dime. A dime is actually smaller than a penny, but it's worth 10 pennies. That's pretty odd to a child in kindergarten or first grade. If you ask them which one they would want, they would probably pick the penny because it's bigger. That means it's worth more. Well, non-proportional materials don't work that way. And we encounter non-proportional materials all over the place. So we need to teach with them. Proportional materials will always come first. Non-proportional is after the concepts are better understood. So let's go back to counting for a second. There are plenty of strategies for helping kids learn to count and overcome the counting errors that we looked at previous. Some of the strategies I'm sure you've encountered. Counting on. Counting on is a great strategy for helping build number concepts and helping build better counting skills. So an example of counting on would be if the teacher said, okay, children, let's start at 5 and count from there. 5, 6, 7, 8, etc., etc. Some children struggle with this because they are still doing rote counting. This promotes rational counting. Have you heard of other ways to do this? How about counting back? So children, let's start at 8 and count backwards. 8, 7, 6, 5, 4, 3. Counting back helps build rational counting. One more example. I'm sure you've done it. Skip counting. We've typically taught skip counting in counting by 2s, counting by 3s, counting by 5s, and counting by 10s or 100s. We usually don't, at least when we're first learning to count, skip count by 6s or 7s. That doesn't come until multiplication, and it's still hard for many adults to do skip counting at that level. So skip counting is typically done with smaller amounts like 2s, 3s, and 5s. All of these strategies help build better number concepts. So, that ends our brief lecture on developing number concepts. I hope you've been able to follow along with this. If you have questions or feedback, I would love to hear both. I need to make sure that this process of recording lectures works well for our flipped classroom, and I guess I'll see you on the whiteboard in the very near future.